Hi, kids! All right, we are going to do a little practice problem. Let's pretend we have a magnetic field that is pointing into the page. That's going to be represented by all these X's. So that would be the negative Z direction. And then let's say that there's a positive charge in this magnetic field. And right at this instant, this positive charge has a velocity that is going that way. So if we were to do our right-hand rule, we would say, all right, my thumb points this way, my fingers point into the page, so my palm is pointing in the positive Y direction, so that this thing would actually move like that. And then, hey, now it's going to be over here moving straight up. So if you did your right-hand rule, it would go this way. My palm would point into the page, and my forces to... So at this bottom point, my force was pointing that way. Here, my force was pointing this way. That's going to cause it to, rotate like this. And then later on, it's going to be here. And then my force would be pointing, hopefully you can see it, be pointing in the negative Y direction towards the middle. And then, hey, guess what? This thing would actually go around in a circle. And you could see that the force is always pointing inward. And hopefully you remember that net force that always points towards the middle, that's called your centripetal force, okay, which is abbreviated FC. And if you have your formula sheet, I would suggest you get it out, because you will see this equation, FC or AC equals V squared over R. And just remember, FC is a special net force. So net force is equal to MA. So a special net force is going to be equal to MAC, which is going to equal MV squared divided by R. Hopefully you remember that, okay, for something, the net force for something moving in a circle. Well, what is supplying this net force? Well, that was the magnetic force. So you're really going to end up with the magnetic force is equal to mv squared over r. Well, the magnetic force is QVB and equals mv squared over r. And then, one of these v's would cancel out, and you'd get QB equals mv over r, and you could answer stuff. Now, how do they actually use this? Now, that's a pretty cool thing just in general, and sometimes you're going to get questions that just deal with this in general. But they specifically use this type of thing because a lot of times they're trying to figure out what is this mass of a certain object, okay? Because if they could figure out what is the mass of this object, they could figure out what that object is. And this is, if you've ever watched any like CSI or any of those shows where it's like, hey, they got this unknown material and then they run a test on it and magically they know what the material is. That's what they're doing here, okay? And that's what this thing is for. It's called a mass spectrometer, okay? And let me just go through the parts of a mass spectrometer. So let's say a scientist finds some unknown material at a crime scene or something like that. Or if they're doing, let's say that they're testing somebody's urine to see if they're, taking steroids or something like that. Again, they would find this unknown thing and they would try and do something like this with it. Now, let me just explain. So what they're first going to do is they're going to take their sample and they would give the unknown material a charge, okay? Remember, the charge is going to be always some multiple of that number, because this was the most basic charge of an electron. The electron is negative, but this is the most basic charge. It's always going to be some multiple of this number. So if they take electrons off of it, it has to be a multiple of this. If they add electron to it, it has to be a multiple of this. It just would be negative, okay? So yeah, just keep in mind if you have a negative charge, it's going to move differently. But then what they do is first, they need to get this charge moving. So how do they get this charge moving? So let's say it's a positive charge. So that's a positive charge. Okay. And if they want to get this charge moving, they're going to put two plates in between here. They're going to make this the positive plate, this the negative plate, which is going to cause it to move this way. Well, instead of running into that plate, they're going to put a gap in that plate so that that positive charged object can just keep going. Okay? And if they wanted to figure out like how fast it's going, you could set it up to UE equals kinetic. Remember where UE is Q delta V equals 1/2 mv squared. Okay, and they can figure out exactly how fast it's going. All right, so then it enters the next part. So this is usually the part 1 of your mass spectrometer. The next part is going to be an area where, and this part is going to be called the velocity selector. Because guess what? Only specific velocities are going to make it through. And let's just say that I want my charge to move straight through, okay, at a constant speed, which means I want the net force, okay, I want my net force to be 0 if I want it to move through at a constant speed. Well, let's say the top plate has a positive charge, the bottom plate has a negative charge. Well, I know my electric field is going to point this way, which means I would get an electric force pointing downward on that positive charge. If it was a negative charge, the electric force would point the other way. Well, if I want it to move straight through, I had better have a magnetic force that's going to cancel that out. Okay, well, if my magnetic force is going to point in the positive y direction, then if you do your right-hand rule, let me just roll out so you can see, your hand's going to look like this. My palm is pointing in the positive y direction, so my magnetic field would have to point into the page. So I would have to have a magnetic field in here that is pointing in the page. Hopefully that makes sense. Well, let's do the math, and I just want to show you something here. So if I do the math and I say QVB equals Q times E, magnetic force equals electric force, do you see how the size of the charge goes away? Which is great, because you know what? When I charged my material, I just know it was a multiple of this. I didn't know exactly how big the charge was, okay? So then my velocity is going to be equal to E over B. Hopefully you see that. So then by adjusting E and B, I can make this thing go straight across. Or more specifically, I can only have the ones that I know are going to be going a specific speed go straight across. You know, so if I set it up so I'm looking for a specific mass, let's say I'm looking for a steroid. Well, I know the mass of that steroid. Well, I could then set it up so that I know how fast it's going, so it's going to be going at a specific speed, and then anything not going that speed, by adjusted here, is not going to make it through. It's either going to run into the top or run into the bottom. Then it's going to enter the detector area, and let me erase this, or at least try to erase this. I don't have greatest eraser, but that's okay. Well, when this charge enters the detector area, going this way, if I had a magnetic field here, and it's going to be a different magnetic field going like this, just like we did below, well, this charge is going to come in and then make a circle and collide. Well, this, does everybody see, would be 2 times the radius. And then if they know that distance, okay, which they could easily measure, then you could use what we did down here. They know the R, and then they could solve for the M, and lo and behold, they could figure out what the material is. But that's your introduction to a mass spectrometer. This is super important. Make sure you understand this. But this is the basis, like again, introduction You are going to watch a video about it and then answer some questions about it, but at least this will introduce you to it. All right. Bye, kids.